Good morning, good afternoon, good evening, whatever time it is while you're watching this, and welcome to the second of my questions about the Flat Earth model films. The first question I've got is that a lot of Flat Earth information seems to say you can't have an atmosphere next to a vacuum. Okay, I can see why that happens on Earth, but the thing is, the atmospheric pressure is actually higher the closer you are to sea level, and the further up you go, changing altitude, the less the atmospheric pressure is. And you don't have to take a pressure at sea level and one at very high altitude to see this. You can drive down a very steep hill and your ears will pop because of the change of pressure, and you need to equalise the change of pressure in your airspaces to the change of pressure outside. So I'm wondering, how does that work? Because surely at some point, if you go high enough, the air pressure will be pretty much close to zero. So what am I missing? The second of the 5 questions in this film are to do with tide. A lot of flat earth stuff I've seen says that water always finds its own level, and that's true enough, because if you have a glass of water, apart from the surface tension, the water will be level. But as somebody that used to scuba dive, I know that you have to keep an eye on tide tables, and they can be different for places on the east and west of a landmass, such as the UK where I live, and even north and south on the landmass along what would be the same stretch of coast. So how does that work on a flat earth model? Surely the water shouldn't change in height much, or should change either side of a fairly small landmass like the UK. The next one is a measurement that I see quite a lot in flat earth theory. 8 inches per mile squared. It seems to be some sort of atmospheric refraction measurement, but how was it derived? How was it measured? Is there any information on that? People say do your own research, but I don't seem to be able to find how this was proven experimentally or where the measurement is derived from. Next up is another landmass question. If you look at the coast of Africa and the coast of South America, they fit together really well, and this is explained by continental drift. That doesn't have to be a globe model or a flat earth model, it's a model of how the continents move apart. On a flat earth model, how does continental drift work? And now for the 5th of my 5 questions, and this is something I didn't actually think about when I asked the first 5, and it's to do with the firmament again. All the flat earth models I see have a firmament which is shown as a dome. However, the centre of the dome is shown over the North Pole, and the closer you get to the edge of the flat earth diagram, the lower the firmament is. So does the firmament change in height, and if so, by how much? For example, H1 and H2 do appear to be very different based on the models that are commonly shown. Right, that's it from me for now, so there's just a few more things I'm pondering. Again, please put the explanations in the comments below and I'll have a look at them. I will, of course, reserve the right to edit any swearing or name calling or anything else from either the globe or the flat earth side of the debate. Tatty bye until the next one.